Hello, my name is Stephen Gottlieb, and I made up the GRE video. At this point, I would just love for you to sit back and view a sample demonstration. That way you get to see a little bit of my teaching style. But we get right into it. You're given this problem. X is an integer. Which of these must be even? Well, the first thing is, what's an integer? Well, an integer contains the counting numbers. And when we count, we go 1, 2, 3, 4, and so on. But the integers also include 0 and the negative counting numbers. -1, -2, etc. So which of these must be even? Now, a couple of points I want to make. 0, 1, 2. Let's just look at these numbers. If you start with an even number, if you go 2, it stays even. If you add 2, it stays even. If you add 2 more, it stays even. If you start with an odd number and you add 2, it stays odd. Every time you add 2 or 4 or 6, a number, if you start with an odd number and you add 4, it stays odd. If you start with an even number and you add 6, it stays even. One last thing. Notice when you go in order, it goes odd, even. Let me try that again. Even, odd, even, odd, even, odd, even. Okay, so when you add 2, your odd or evenness won't change. When you add just 1, it does change. Well, does this have to be even? Of course not. Start with an even and add 1, and now it's odd. So it's not this choice. Adding 2. When you add 2, odd evenness doesn't change. Well, I want to see if it must be even. Well, if I start with an odd number and I add 2, it stays odd. Now, if you look at these last two, let's just suppose for a moment 3x must always be even. Well, then this is even too, because this 3x is even, and I add 2, it's even. Well, which must be even? There should only be one of them. Well, it's not if it's this one, then it has to be that one. If it's that one, it has to be this one. So it's not going to be these. Another argument is let x be 1. 3 times 1 is odd. By 3 times 1 plus 2 more. It's 3 plus 2, which is still odd. It's this one. Whoops. That should be x, excuse me. It's this one. Now, okay, how can we have seen that without going through all of this? So some of you won't know what I'm about to say. That is, you didn't come into this video knowing the following. So this is one way of doing it. What you need to realize is that every even number, 2, 4, 6, 8, 10, 0, it's 2 times an integer. 2 times 1, 2 times 2, 2 times 3, 2 times 4, 2 times 5, 2 times 6 is 12. If you multiply 2 by any integer, you get even. Well, in this problem, I can factor out a 2. 2 times x is 2x, plus 2 times 2 is 4. Now, x is an integer. I don't care if it's odd or even. You add 2, you get another integer. Again, I don't care if this is odd or even. I know one thing. When I multiply it by 2, it's even. When I multiply odd numbers like 1, 3, and 5, by good old 2, I get evens. If I take even numbers, 0, 2, 4, 6, and I multiply them by 2, I get even integers. 2 times any integer is even. An integer plus 2 is an integer. You add, multiply it by 2, it's even. So you could have gotten it on that note. Or you could say, you know what? These don't have to work, so this one does. Multiply 2 by any number, it's even. So here's another way of getting it. This is even because it's 2 times an integer. You add 4. You add 2 and 2 again. Every time you add 2, odd even doesn't change. So if this is even and you add 4, it's even. This is the correct answer. We argued it 2 different ways. We argue that these can't be the answers, so it's this one. Then we argue that I can factor out a 2. Alright, this completes the sample demonstration for my GRE video. I wish you great success on your upcoming exam, and I would just love to thank you for viewing my video.